launch the recording. Yes, Raffaele, floor is yours.
Okay, can you see my presentation?
For the moment, I have a black screen.
Oh. Okay, I hope.
Something, yeah, I think something's coming up because I see at least a mouse pointer.
I'm not sure what's happening on my PC.
That's the demo effect. You know, every time you want to share something, then
it's still blinking. I don't understand why.
yes, there you are. You can see your screen, Raffaele.
Do you see? Okay.
Yes, yes, yes.
Okay, perfect. So good evening to everyone. Thank you for being here, and thank you, Sebastian, for your invitation. I'll introduce you C128 lib, a new library for creating games and application on Commodore 128 using assembly. In this presentation, I'll show you some information like who I am, why I choose to create this library, how this library is organized, and what are the main components. Obviously, we see some code. I'm a developer, I like theory, but I need code. And then the references for using this library or to contact me. So we can start with the first topic. My name is Raffaele Intorcia. I live in northeast part of Italy between Venezia and Trieste. I started to play on a Commodore 64 in 1985, then quickly moved to a C128. And then at the end of the 8-bit era, I moved to 8088 with DOS, Windows, and other things like that. My professional career started as a developer on LAMP stack, and now I'm working as a team leader, Scrum Master, desktop and web software developer. I don't have too much time to do all these things because Scrum Master takes me most of the time. And these are my contacts for LinkedIn, Twitter, GitHub. I have not really updated blog on Commodore stuff. And obviously, this is my email address if you want to contact me. So why did I choose to start this new library? There are some preconditions. I was and still am a proud user of C64 lib. That's still a great source of inspiration. And I want to make something similar to C128. I like very much assembler, and I'd like to create something with Gradle and Circle IO for CI/CD toolchain. I fixed also some expectation like the library should be simple for novice, should help assembly practitioner to write code to make more readable than assembly, obviously. But I want to make it also helpful for bigger projects. I like open source, so it should be open source and MIT list licensing. Sorry, I've got the flu. I don't feel I don't feel good. So anyway, as I said before, I am a user of 664 lib, and I took a source of inspiration. So I created a GitHub organization, which is available on the link you can see github.com/C138lib. This organization contains several repositories, which are the components of the whole library. GitHub has a project feature for issue managing, and every repository has its own issues A project lets you see the big picture. Developer use discussion for coordination. At this time, there are two developers, me and John. So let me say, ciao, John. It's a pleasure to work with you. At this time, there are 5 repositories that are common, chipset, framework, samples, and reference. Common and chipset are the simple one. They contain many labels for the most important memory addresses. In common, you can find a label for kernel, routine, screen editor, etc., but also macros for simple math operation. Most of them are taken from C64 lib. I honestly didn't work much on it, so I grabbed content from that library and added some particular addresses for C128. Chipset is the same, but also as a module to work with BDC that is capable of 80-column screen on a separate video channel. That implies that the C128 has an independent double screen solution. VDC is more difficult to program because it has an internal video memory, doesn't share a screen memory mapped on RAM, and it is accessible only with 2 registers for address and data. It has some internal register to perform every operation. So chipset maps all these registers and provides macros for reading and writing data to VDC. New macros and for more advanced operation will be implemented in the future. Just a quick example of code. Common contains basic start 128, the classical instruction to create the SYS instruction. Chipset contains some macros to make more readable code, like this to set border and background color to black. Framework is the newest repository. It started some weeks ago. Its purpose is to take advantage from a common and chipset to provide functionalities to create complex application. At this time, it contains 2 modules for array manipulation and a string manipulation will be available soon. It's built to be a framework, but in many cases appears like an assembly code repository. Sample has been created just to provide example and to show how labels and macros work, just for example and learning purpose. Reference, as the name suggests, it's a navigable resource for reference. It contains reference for memory, for chip, kernel. It's a work-in-progress project and takes its contents from many sources like book, official references on the web, and other resources available. Okay, so let's start with the most important part of the presentation, code. We take a short journey starting with the classic example, the hello world. This is the basic example, a minimal use of common library. Line 2, there is a SYS declaration setting entry point to 1C10. Then the entry routine at line 6, it calls print string with length that obviously prints a string with a length of 12. A string is defined on line 11, and then there are the classical import to make use of the basic start and the print string. So this is the one. And if you try to run this program on Vice, you'll get this output. I also made a list to see how basic start composed the SYS command. Next example is just a little bit complex by adding a Go80 instruction. This is just a kernel call to move the output to the 8-column monitor. As you can see on Vice, you can see the 8 column that displaying the hello world string. Next example is more complex. Is just to show how sprite can be handled. These macros are on chipset and are specific to sprite handling. Take this code. Here are the clean screen call, a border and background color set to black. Then you have the sprite 0 definition, color, multicolor positioning using shadow registers. The last macro tells how to move sprite 0. Argument can be used to set which sprite to move, speed of sprite, quadrant, which means direction, and delta xy to xy, to define amount of movement. It's something similar to move SPR basic 7 command. C128 will move sprite according to arguments, so you don't need to care about it. This macro can save you from writing all these instructions. These are 22 LDA and SDA, which are done with this single macro. And this is just a video. I probably can start. Yes. Of what happened by running the program we saw on the last slide. As you can see, the sprite move, and there is no instruction of inside my program to move the sprite. The system moves automatically. Okay. But how to integrate C128 lib? This library can be integrated by using Gradle. Gradle is a build automation tool for multi-language software development. You only have to create a build Gradle file. Inside this file, you set the assembler plugin, which came with the C64 lib, and inside the Reto project node set assembler as a compiler, library folder where library will be downloaded, and which library you need and what version of them. After this, you have to install Java JDK and Gradle. If everything goes well, you can use Gradle command to build your source code, or Gradle clean to be sure to clean your previous build. These are the same command used to develop C128 lib. Every repository is configured to start a build on Circle CI. Every push on developer master branch will trigger a build on Circle CI. This helps to understand if your source code works outside your computer, but build status will be reported on your repository page on GitHub. On my Kick Assembler project, there's an additional step that takes the application PRG file built on Circle CI when there is a push with a tag, and send it back to GitHub automatically. This won't apply on C128 lib because there's no PRG to deploy, but it's an interesting feature for the project. Next slide. 10 slides are made to show you some useful interesting macros. Some of them are taken from C64 lib, but many others are new. Common contains a math module. Inside the two math macros were added to simplify division. You can divide a 16-bit number with another 16-bit or an 8-bit number. Then we have video. We saw something earlier in this presentation. You can see macros for cursor positioning and string right. These macros use a kernel routine and works with the 14 or 80 columns. Going on chipset, there is a CIA module which contains macros for setting Big Bang detected joystick fire. Next, there is an MMU, which is specific to C128. A great effort has done to make this module because there are macros to set the main configuration on your application. You can set common RAM amount. C128 has an 8-bit CPU, so only 64 kilobytes can be addressable at time. To gain access to 128 kilobytes of memory, CPU can switch to different bank, for example, by using set MMU configuration. Common RAM is a part of bank 0, which is always visible despite of the bank currently used. This consent to have a piece of code always available. Amount of and position of common RAM can be configured with the set common RAM. Then we have a sprite. It's a bunch of macros specific to sprite handling. It's based on big2 labels and shadow register. We saw some of them in the other slide. You can enable or disable sprite, move sprite, set color and multicolor, or set an automatic move as we saw. VDC is completely dedicated to 80 column chip. You can switch to and from 80 column, read and write between system memory and internal VDC memory. No specific LAN for this module, but I thinking about intensifying work, about abstraction of functionalities here or on framework repository. For big2, it's available a bunch of macro for border and background color selection, handling basic IRQ, screen editor IRQ. There are some macros to select the big2 configuration, screen memory position, charm memory position, etc. It's facilitated by using talking labels for easy configuration. There is not too much about framework. Currently, it's available only a bubble sort inside a sort module. It's planned a quick sort. New macros for string manipulation are currently under development. New macros for array manipulation are planned. And then last topic is reference. You can reach GitHub organization. You can look at the same information, at some information about how to use library as a user or a developer. You can take a look at the memory map and reference. And obviously, if you want to talk to me, you have, if you want to have more information or participate, is my email address. As you can see, there's already a lot of work done, but many functionality are planned. So if you are interested in some way, stay tuned and feel free to ask it. New users are welcome, new developers are even more welcome. I'd like to discuss new ideas to improve the library more and more to make it more complete. So I have done, and thank you for listening to me.
Thank you very much, Raffaele. I don't know if there are any questions from people in the call here. In the meantime, I will look in on the Facebook page if there is any. Oh, I see a comment here. What is it? Steve Commodore, who says, good evening, everyone. Well, thank you. Good evening to you too. We have like 11 people attending on Facebook, and we are like 7 here. I don't know. Any questions? Yes, no? Otherwise, I have a couple. Have you tried, for example, on the Ultimate 64 or on devices like I don't know, maybe the Mega 65? Because I think the memory address is supposed to be the same, but I think that in the past some people have tried with these devices a few things, and from time to time it can be that it's not fully compatible with the original hardware. Do you have an experience with that?
No, I did this only for Commodore 128. I talked to Maciej, which was the author of 64lib, to understand if that can be realized a library that can be used by the same user by changing.
Cecile, you need to mute. I will mute you. For some reason, you unmute.
So I didn't try it. I tried to work only with Commodore 128, but I don't know if in the future can done something different. I don't know at this time.
Okay, I see a question from Wilfried, a former speaker at All Talks. He says, "Great talk. Your library looks very interesting. Is it also possible to combine it with C?"
I don't know. I don't think at this time I will try to do this, but maybe in future, probably.
Okay. Thank you for that. I'm checking if there are, if someone in the attendance here in the Zoom call have questions, don't hesitate. I'm just looking here if there is anything new. No. Okay, but if someone has questions later on, maybe you can still put it in the chat. Then I would say many thanks, Raffaele. I will stop the recording now.